I forgot to say something that was important. So I'm going to add it to this note, okay? Um, let's see. I'm going to try to make this fast. Screen share. Let me press enter, Zoom. All right. Okay. So here, this is where we were. Remember, I was kind of talking about some things we could figure out from here, but I really need to go over something else in addition to this, okay? So let's look at a comparison of PES spectrum, all right? I'll just kind of do two side by side. And let's go like this. Let's just we're gonna keep it real simple, okay? We're gonna go like this. Oops, don't. Okay. Okay, so I hope that you see the difference, and I'll write down what it is. Right, the difference is difference in terms of binding energy. Okay, so what do you notice is a difference in terms of binding energy? Right? Well, what I notice is that this spectrum has a much higher binding energy to begin with. Sorry, guys. The spectrum, higher binding energy, right? So, right, because he starts, remember we said the closer you are to this, the higher your binding energy. And we see that this is closer to Y radius. That's how we know it's got a greater binding energy, right? That also means that it is closer to the nucleus. The question though, guys, is, oh my gosh, what just happened? Okay. The question though, guys, is why, okay? And you need to understand this. And that's why I had to get you another video, because this is the first energy level. And this is also the first energy level. So you might be thinking, well, shouldn't they be equal distance from the nucleus because they're both the first energy level? And what we're going to do before we go straight to the answer is remember Coulomb's law, okay? And I said we're going to talk about Coulomb's law a lot in the next few days, and we are. And what he says that we've got something about distance here. Now, this is not the actual mathematical formula, but these are the variables involved. You won't need to calculate. But here we have charge, opposite, right? They have to be opposite. I mean, they don't have to be, but we are talking about oppositely charged particles, right? We're talking about the negative and the positive, the proton and the electron and the proton. And right, because what we said was our nucleus here is positive, and we had talked about the closer the electron to that positive nucleus, the stronger the Coulombic attraction and the greater the binding energy. That's what we said in the last video. Well, what we see now is, so we talked about distance in the last video. So what I'm talking about now has to do more with charge, because we are discussing energy levels that are the same. We are comparing the first energy levels binding energy here with the first energy levels binding energy here. So we can't say that the difference is based off of the distance anymore because they're both the first energy level. So what's going to happen is that we're going to say that the difference is based off of the charge when in fact it is, right? That's what's going on here. So I ask yourself, or I ask you, you know, these guys could even have the same numbers of electrons or similar, or, you know, on the same energy levels. But what you need to notice, or what I can infer, and you should eventually infer, is that this atom compared to this atom or element, right, has more protons in the nucleus, right? And the more protons you have, the more positively charged it is. making it more positively charged. That's what I'm going to write. Making it more positively charged. And that's important to realize, okay? And the only way I know this is by either just comparing what elements they are and looking at their atomic number, or but I could also infer it from looking at that binding energy of the first electron shell. And since it's more here, it must be that this nucleus has a greater charge, okay? So if, yeah, and that's what I needed you to realize. That, in fact, is what I needed you to realize. Okay. All right. And I'm going to leave it at that. I told you to be short. Okay. So, yeah.